Hello, my name is Rob Reynolds. Sorry about that. Got interrupted, and this is section 3.4, part 2. We were talking about the product rule, and so we were saying you can't just do the derivative of x squared, which is 2x, and then the derivative of e to the x, which is e to the x, and that's not how you do the product rule. We decided the product rule was either this, or I was trying to use 1d2 plus 2d1. So if you haven't watched part 1 of this video, go back and watch from the beginning. I haven't gotten very far because I'm still in example 1, but here's part B. So this is not how you do the problem. Instead, let's do the rule. And the rule says 1d2 plus 2d1. So we'll write down the first function, which is just x squared. The derivative of e to the x is e to the x plus the second function, which is e to the x, and then take the derivative of the first, which is 2x. And as I was explaining in part A from the previous video, that the simplified version is always the factored form. So it looks like I can pull out an e to the x because that's common, but it also looks like I might have an x that's common. So I'm going to pull out an x e to the x, which literally just means divide each term by x e to the x e to the x. And that leaves me with this guy with just x plus, oh my gosh, I got a 2 left, and that's about it. X plus 2. Again, this is the derivative of this thing, and you can see why I like it in factored form, because it's really simple to see that this function, the derivative, the root here is going to be -2. That's a 0 at -2. And I couldn't have told, it's not as obvious to see it if you leave it in this form. So this is why we like this in factored form, the simplified form. We're not going to talk about the -2 yet. We'll talk about that in section 2. But for right now, leave your derivatives in, yay, the author did it too, in factored form. So the quotient rule is a little bit more complicated. Here's the actual end result, but you may ask, well, how did you get this? And so I've derived this for you again by using some of the techniques from the product rule. So if you're interested in wondering where this formula comes from, here's the proof. But what we're going to do is if you have an f at x function and a g at x function, I actually do kind of sing a song for this thing. We're going to call this g at x function the low function. So low, and then you take the derivative of the high, we'll call that d high, minus, so the low, and then the derivative of the high function, well, that's the derivative of, so you can see the derivative of the high, d high, would be f prime, why? Because the high function. So the song goes low, d high, minus high, d low. I should sing it for you so you can, all over low squared. So you have to come to class to get the actual song, I guess, but low d high minus high d low, square the bottom and off you go. Boop, boop. So if you want to just YouTube this and you'll see, oh my gosh, it's a song that will just get stuck in your head. We can commit, I mean, songs is one of the ways that we commit lyrics. We know a lot of lyrics, have them memorized, and so singing some of these definitions can help you memorize them. Oh my gosh, there's even the quotient rule for this guy if you like the rocker tune, so learn the rocker tune. I won't play those for you, but if you were in my class face to face, you would have to endure listening to those. So here we go. The derivative of this quotient, by the way, you cannot take the derivative of the numerator and then take the derivative of the denominator and just divide them. We showed you on the previous video that's not how it's not going to work. So instead we're going to do the quotient rule, which says low d high, take the derivative of the high minus the high function, x squared plus 3x plus 4, all of that times low d high minus all of the d low is the end of that song. Oh no, the end of the song is, well, really, the song, I should sing the whole thing for you. It's low d high minus high d low. They did square the bottom, and then the song says, and off you go. And off you go means after you do this, you've got a lot of work to do because you have to simplify the thing, work on factoring it. So I will not accept this as an answer. You need to work on multiplying this out, combining like terms. Let's FOIL this up here. What is that? 2x cubed plus 3x squared minus 2x. Well, jeepany crikeys, I'll just bring that down here. Minus 3. I'll distribute all of this for a 2x cubed plus 6x squared plus 8x, and then I'll distribute the negative minus 6x squared minus 8x. And I think I'm just going to leave this again in factored form because I might be able to simplify, combine my terms, and maybe find another x squared minus 1 factor from the numerator that I could cancel later. So it looks like the x cubed terms drop out, which is nice. So I'm looking now at my x squared terms. And it looks like I have a negative 3x squareds. And my x's are negative 2x for negative 8x for negative 10x minus 3. That does not factor, and because it doesn't factor, I would be inclined to say that's the answer. Yay, the author got the same thing. Oh, there's a part B for this one as well. And well, you might think that it says using the quotient rule. I'm not sure I would use the quotient rule for that because we know the derivative of e to the x is just e to the x. So this, but if it says use the quotient rule, I could rewrite this. I don't want to, as this. And then from here, I could do low d high minus high d low all over low squared. I bet the author did it that way, but I'm just going to give you a rule because I don't like to work things the hardest way possible. So I would say the derivative of e to the negative x is, and you don't know about chain rule yet, so maybe I do have to do quotient rule. But the derivative of e to the x is e to the x times the derivative of this little guy, which is negative 1. And I just did a little chain rule on you, which we don't get that for a couple days. So maybe we should be doing the quotient rule, low d high minus high d low all over low square. But look, he gets the same answer as I do because I just, oh shoot, I shouldn't have introduced the chain rule, I guess, to you. But you certainly can follow this example. Since I'm here, can I just give you a nice fast rule? The derivative of e to the 5x is e to the 5x. All we have to do is take the derivative of that 5x, which is another 5, and then the final answer is 5e to the 5x. So I'll show you that shortcut for e to the x. I mean, it says use the quotient rule, so I guess I wouldn't give you full credit. If your work is down here in yellow, I can see you're not following the directions, which is use the quotient rule. And oftentimes I'm looking to see if you understand the method of madness. So I need to see you demonstrate content knowledge for the quotient rule. And it's not about getting the answer. So you need to show it. So this one says find the tangent line, which means we need to find the slope. And the slope is the derivative. So I'll do the derivative. Low d high minus high d low all over low squared. And then what I would do is I would evaluate the derivative at, when I get done simplifying this thing, I'll probably evaluate it at f at x, and x is 3. So I wonder if I could distribute combine like terms here, multiply it out. Be careful, this negative is going to get distributed. So this is really 2x cubed plus 2x, but when I distribute it, it's really 2x cubed minus 8x minus 2x cubed minus 2x. And I think those x cubes go away. So just maybe negative 10x. over x squared minus 4. I hope I got the derivative correct. And then if I plug in a 3 here, I get negative 10 times 3 over 3 squared minus 4. I just saw an error that this should have been squared, which means this should have been the squared, which means this is going to be squared. So negative 30, because the rule says low d high minus high d low all over low squared, and I forgot to square it. So I get negative 30 over 9 minus 4 is 5 and 25, and I think that reduces to around a negative 6/5. Now remember, that's the slope of the tangent line. And it says find tangent lines by writing the equation of the line, and the equation of the line that I use is this y equals mx plus b. You just found what m is. The y value is right here, so I would write down 2 is equal to negative 6/5, the x value of 3, and I would just solve for b. Oh, crap. I need 5, so I'm going to call this 10/5. And then when I add 18, I get an 18/5 for my b value. So the final answer would be y is equal to negative 6/5 x plus 18/5, the equation of the line. Let's see. Oh, I did something wrong. 28. What did I do wrong? Oh, I see. I didn't add 18/5. So if I add 18/5 to the 5/5, I get the 28/5. Oh my goodness. I didn't add this very well. But the author did it, and remember the author's using the y minus y, so maybe I should too, x minus x, but somehow we should end up with the 28/5 for the y. Example 4 says, well, let's not use the quotient rule if we don't have to. It says use extended power rule, which really basically just means simplify first. Don't do low d high minus high d low if you don't have to. I mean, if the directions say use the quotient rule, then you have to demonstrate that content knowledge. But we could do, if it just says find the derivative, it's easier just to rewrite this real quick, and then negative 5 times the 9 is the negative 45. And remember to decrease it to be, and you could write that back with no negative exponents, which is usually considered more simplified. So same with this guy. We probably want to think about this as being each term being divided by t to the 6th. So this is 3t to the 10th minus t, 4t to the negative 6th, and then taking the derivative of that is 30t to the 9th. Well, that would be plus 24t to the negative 7th, because again, decreasing the exponents. That was much faster and easier than doing low d high minus high d low. So the purpose of example number 4 was saying, hey, just because you see a quotient, you shouldn't always just dive in and do the quotient. Think about how to simplify it first, unless the directions say use the quotient rule. So I think this slide is kind of introducing what I just had introduced earlier to you. So I guess I wasn't that far ahead. The derivative of e to the 5, where k is some constant like 5, then they're saying it's 5e to the 5x. And that's the definition that they're giving you there. But the reason why it's working is because of this u du discussion, which I don't mind introducing, but we really don't get this a whole lot until we hit the chain rule, which is, I think, 3-6 or so, a couple more sections. But if you let u equal, in this example, this 5x, then if you do a u sub, just remember we need to remember to take the derivative of u, and the derivative of this side is just 5. And so this is where that extra 5 is coming into. The derivative of e to the u, then by definition, is e to the u du. And that du is the derivative of that u sub. So we'll get more into that, but that sure is helpful for that example. And so when you're doing the product rule here, 1 d2, well, the derivative of d2, we just talked about it, is 5e to the 5x. Plus 2, and then d1 is just 1. And it looks like, again, factored form, I could pull out an e to the 5x. That's what's common, leaving me with just x plus 1. And that's that's the derivative. So you can practice part B, and again, worked out solutions are here. Remember, you have a handout that you could hopefully are downloading, and you're pausing the video and working ahead. When you get to story problems that talk about instantaneous growth, that just means the derivative at that particular point, or sometimes it's the rate of change. But the instantaneous growth rate, the rate of change is the derivative. So they just want you to find the derivative of this thing. And again, I feel comfortable that you could. Now, by the way, you cannot. Oh my goodness, you cannot rewrite this by just bringing this guy up. Ooh, that's a common mistake. No, 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 no. This is not 400. I don't even know what you would do. Would you say plus or times? Whatever you did, you'd be wrong because that's part of a sum down there. So you really do need to do the quotient rule, low D high minus high D low. So don't try to mess that up and come up with a different answer. They have worked out solutions here. There it is, low D high minus high, and then here comes the derivative of the low is all of this in green. So they've got it worked out for you. And of course, you can use your graphing calculators to graph that as well. Here's the books worked out solutions and their graph. The last thing I'm going to say, I won't work this problem out, but you can see we have a product here in the numerator and we have a quotient. So sometimes when you're doing the quotient rule, low, D high. So when you're taking the derivative of the high here, you need to do the 1D2 plus 2D1 rule. And then remember, you're within the quotient rule, so it's going to be minus, so low D high minus the high 4x e to the x, and then the d low, of course, is 2x, all over low squared. So again, I would encourage you not to multiply this denominator out because the goal would be hopefully in the numerator. In fact, I kind of see something already. You got an x squared plus 1 here. It doesn't look like it's possible. Maybe it's not possible, but if you could get another x squared plus 1, you could factor that out and cancel. Oftentimes that does happen. It doesn't look like it's going to happen in this case because it looks like they just left the final answer here. So there's all sorts of review problems. Continue working on these, and if you have questions, feel free to email me your questions. Thanks.